Okay, sorry. Okay, thank you. So I will talk about or give a short overview of the work we've done in deliverable 1.1 and 1.3 in this project. So deliverable 1.1 was more focusing on kind of setting the stage or giving the context of big data and the transport sector, and deliverable 1.3 really dived into the methodologies and the tools which are used in the context of big data. So I'm going to start with a short introduction of the 4 V's of big data, or the 5 V's, which are kind of or give it a short definition of big data. So big data is commonly defined through its main challenges. So big data is called big data, of course, because of its volume. So if you look at conventional databases, they are usually not able to ingest and store these huge amount of data. So for example, it's predicted that car manufacturers will produce in 2020 111 petabyte of data with their cars. That's one of the challenges coming along. Then the second, of course, is the velocity of big data, meaning that you have kind of now streaming data, a lot of sensors, for example, producing new data every second or sub-second. So you need to be able to stream this data and to really analyze it. Then, of course, you have a huge variety of data. So you have different data sources, different data formats. You have unstructured data, which you need to be able to store in one place. So that's again where conventional databases come to their limits. And then you have the veracity. So in conventional database management systems, you have kind of an assurance for your data quality inside, but this is not the case for big data technology. So there you can end up with faulty data or incorrect data. And then, of course, the 5th V is kind of the value or the goal which you pursue while doing data analytics. So you big data itself has no value, so you need to have a task or a goal. And so what we did, or what was done in also D1.3, is kind of to simplify the really complex technology environment which you need to really handle big data, and break it down into 4 layers, which is really a simplified picture, because in general these layers are interconnected. But I encourage you, if you're interested, look into D1.3. We took some effort to explain every layer and make the connection also to the transport sector. So the first layer, of course, is the hardware layer, which needs to be able to kind of deal with huge amount of data, so storage-wise, memory-wise, CPU-wise. And then on the next level, you have the management layer, meaning that you need to find an optimal way to distribute your resources coming from your hardware. So that can be a just normal operating system, or you can use a container or Docker system. And then, of course, you have the platform level, which is the most commonly known, I guess, is the data storage system HDFS, which comes from the Hadoop environment. And then only on top of that, you have the application level, and that's where your algorithm or machine learning tool comes into place, and thus really do the task you want to reach. So now, just to get into the topic, big data in relation to transport. Is there any data specifically interesting for transport? So, of course, there's no exact definition, but you can say, okay, you have all the traffic data, meaning coming from traffic operators or related actors. That can be real-time or historical data, for example, train schedules. Then you have a lot of sensor data, meaning all the vehicles, trains, cars, whatever. They have a lot of sensors like, of course, GPS, fuel level sensors, tire pressure sensors, and so on, which collect and produce data. Then, of course, you have tracking systems for freight vehicles. Then you have some external data, which can be interesting, like weather or event data, which interacts with your transport sector. And then you can have social network data, which also might contain useful information. And so there are different goals in transport which you can use. So now, coming from the data, one can formulate goals which are specifically for the transport sector. So this might be reduced cost for maintenance, or increased energy efficiency, or optimal use of the existing infrastructure, or reducing environmental impact is also a really huge topic. And only with this two, one can now kind of formulate tasks, which are then the algorithms or tools or software which is doing the trick with the big data. So you can have a predictive or prescriptive maintenance algorithm, or you have a route optimization tool, or you do you have a real-time traffic control system. And I just want to give two short examples. So this is an example from our colleagues from WNRI. So what they wanted to do here is show schematically the situation in the public transport sector. So here it might get clearer that you have different actors which kind of produce or own data that might be useful or interesting for certain goals in the transport sector, or in the public transport sector in this case. So on the one hand, you have authorities and operators, then you can have city planners, or people who know about the infrastructure, and then you can have the public or private users. And in order to reach the goals which are indicated on the right-hand side here, you need to be able to connect and share the data which is produced or owned by the different actors. And then we have a more technical example. This is done in deliverable 1.3. So from my colleagues, this is data analysis using a really common algorithm from the Spark environment, the K-means algorithm. And what it does is it clusters data in a most optimal way. And then you see here around the New York area, 8 clusters for Uber pickup counts, according to 8 colors, as you can identify them. And what they did is they turned this analysis into a benchmark. So they really looked at every operational step of the algorithm and tried to identify bottlenecks and optimize it with the data set sizes, so that other people are able to use it for their own purposes. So that's so far from me a short introduction into D1.1 and D1.3. So if you're interested, we're very happy if you take a look, download it, and read any further. So thank you so far.